Today I'd like to take a look at errors in hypothesis test. So please open up your study guide to the errors in hypothesis test section. Now when you perform a hypothesis test, you will make one of two decisions. Either you're going to reject H0 or you're going to fail to reject H0. Now when you make one of these decisions, there is a chance that you could be wrong. In other words, you have made a mistake. There are two decisions that we can make. Either we reject H0 or we fail to reject H0. Each could possibly be a wrong decision. Therefore, there are two types of errors. Let's talk about those errors. Now, a type 1 error is when you reject the null hypothesis that is really true. And we denote the type 1 error by alpha. Alpha equals the probability of a type 1 error. Now recall that alpha is also the level of significance that we choose to set on the onset of our experiment. So once again, a type 1 error is when we reject the null hypothesis. We got a low p-value, we have sample data that is very extreme, and it allows us to reject the null hypothesis. However, we later on find out that the null hypothesis is really true. So we made an error. And that error is called a type 1 error. And once again, we denote alpha as the probability of making a type 1 error. Once again, alpha is also the level of significance. Now, let's take a look at two superimposed graphs here. We're going to let alpha be the level of significance. It's also the probability of a type 1 error. So at the onset of our experiment or our study, we set the level of alpha, our significance level, and notice the auxiliary line is drawn to represent that region where we begin to doubt data. And we call that our line of rejection. As soon as our sample data crosses that line, we're going to be able to build up enough evidence against the null hypothesis and we'll be able to reject H0. Now if our sample shows a value that is extreme, in this case out in the far right tail, we would reject H0. However, we might have made an error and the sample data we collected may just be unusual or extreme. The X bar is really part of the H0 curve, but we mistake it as being part of the HA curve. So the top graph really represents the null hypothesis and what we assume to be true in the null hypothesis. The bottom graph represents HA. In this case, we're looking at a right tail test here, and we're assuming in HA that mu is greater than some specific value that was stated in the null hypothesis. So we superimposed these two graphs here. We put one on top of the other, and we went ahead and drew our line of rejection at the level of alpha through both the top graph and the bottom graph. Once it crosses that line and that probability value, the p-value becomes so low that we begin to doubt that our X bar really comes from the graph of H0. We reject it and say there's sufficient evidence to suggest that this X bar value really belongs to the graph of HA. However, once again, we could have made a mistake, and that mistake is called a type 1 error. And the probability of making the type 1 error is denoted by alpha. It's set at the onset of the experiment by choosing our level of significance, and that's once again the probability that we made an error. In other words, we rejected H0 and we shouldn't have, because we later found out that H0 really is true. Now let's talk about a type 2 error. A type 2 error is when you fail to reject the null hypothesis when it is false. The type 2 error probability is denoted by beta. Beta equals the probability of a type 2 error. The X bar that we sampled is really part of the HA curve, but we mistakenly think it is part of the H0 curve. So if our p-value came out to be too high and it didn't cross that line of rejection, we would fail to reject H0. So we weren't able to conclude that there was sufficient evidence to suggest HA. However, we later found out that HA really was true. We failed to reject, we made an error. That X bar value really belongs to the graph of HA. Once again, here are our two graphs. We have the graph of H0 on top and the graph of HA on bottom. Now